Okay, so question number 10. This is Calc 30. And this is section what, 2.3? Okay. So this question says, here's a parabola, and I've just sketched it out for you. That's the parabola right here. And it says, find the equations of the tangent lines that pass through this point. So I put that point on my diagram as well. So what we're looking for is, in red here, we're looking for the equations of this line that would run through this point and tangent to the curve here. But there's also another point somewhere over here. Okay? Now, we don't know yet what those x values are, but the only thing connecting a line passing through a point and touching the parabola here, well, we know that there's some kind of slope that's involved, right? If we can find the slope, then we have a point in the line, we can find the equation. So what do we know about slope? Well, the slope of this tangent line is obviously connected to the function here, this one. And so when we take the derivative, which is what I did over here, then I know that this derivative is the slope of any tangent line that runs, that touches this right here. See? I can calculate all of these slopes by starting with this equation, or that expression. So that now I do. Now this is the tricky part. I know what slope means. This is what slope means, right? It's the change in y value divided by the change in x value between any 2 points. So the points I'm actually interested in, obviously, is this point, but I'm also interested in a point somewhere on this, somewhere on this graph, right? Wherever this tangent is. And so how do I express, or how do I show that I'm talking about this point and a point on the graph? Well, the point on the graph, any point on the graph, if you're talking about in general terms, would be some value x, and then its partner value is the x squared plus x. That's what this is right here. Okay? So you don't have to know, really, you don't have to jump right to here and say, boy, I would never have guessed this. But what you want to do is you want to take a look at all of the pieces of this puzzle and find out how they relate to one another, right? And this is a very, very important skill moving forward in calculus. You don't have to know exactly what equation you're going to draw at the beginning of the question. But what you want to do is you want to say, okay, derivative is the slope. Slope between 2 points. I'd like that. I need that because I'm trying to find equations of a line. So then you write this formula down. It's like, okay, well, slope is right here. I do have an x and a y value already. That's one of the points. How can I fit this in here? Oh, right. X and whatever y equals. And so that's how you come up with this. And you put it all together and you look and you say, hey, I just have one variable that's missing here. If I actually somehow solve for x, I might be able to get the actual x values that I'm looking for here. So that's what this is. This is just multiply both sides by this and gathered all like terms, factored, use the zero product principle like we did last year, and then you say, okay, I know what x values. That's my solution, right? X equals 5 and x equals -1. And it just so happens that when you solve that, because here's the point, there's another point on the line, I know what the equation of the slope is, I put it all together, my answers are going to be the x values, okay, that relate all these things. And so the x values are 5 and -1, okay? The question asks for equations, so I need, first of all, I need 2 things. I need slope, I need a point. Here's a point that's on both these lines, right? We know that. But what about the slope? Okay? Well, here are the points that it touches the parabola, which you really didn't need that, but I just thought, well, I'll just show you that -1, 6 would be one point right here, and then 5, 30. This is not to scale, but those are the 2 points, and that makes sense. So if those points are reasonable, you know you're on the right track. So how do I build the equations for this question? Well, point slope form would be handy. Here's the point we're going to plug in here is 5, 30, right? That's this point for the first one. But what about the slope? Well, you have an expression for the slope, right? That's the derivative. And this slope is going to be where the tangent line is at, x equals 5. So if you plug 5 in, you get a value for the slope of that tangent. And that's why I put 11 right here. You work that out, you get an equation for this first tangent line. That's the tangent line that goes right here, this one I've been outlining. Then you turn around and you look at your other x value, -1. You do the same thing. What's the slope at -1? Well, it's actually -1. So you can plug any point in you want. Yeah, I did these points that I found. You could obviously use 2 and -3 for both these equations as well. Doesn't matter. But I used 1 and 6, or -1, 6, right? And then here's the equation, y equals mx plus b for the second line. Now, I don't think I've actually checked those answers, so you can check those answers. Did anyone else get this? Those of you that were able to get this question? Are those something like, yeah? Okay, so upon further review here, it looks like over here, this point value here is not 6. This is not a constant in the equation, that's actually x. So, let's fix that up. And that's going to be a plus a -1, so that should be x there. So that's going to be 1 minus 1, that's going to be 0. So my drawing to scale should have been to scale. Then 6 and 0 would have been quite a bit different. So that means that over here, what do we need to change over here? I guess this right here is just going to be 0, right? So it's going to be y really minus 0. So that's -x minus 1, and that would be your equation there. So how does that look? What do they have in the solution manual there? Do they have it in kind of general form?
Yeah, they just make it equal to 0.
So they 11x here minus y minus 25 equals 0?
Yeah.
And then over here, x plus y plus 1 equals 0?
Yeah.
Okay. Okay, good. That's why you should always check your work. Awesome. Okay, so that's number 10 from 2.3, and that's sort of how you tackle that. And again, the big part, like the iffy part is right here. How do you even get going, right? So I would strongly encourage you to do 2 things. Draw your diagram, right? Draw your graph, sketch it out, take a look at what you're looking for, and then write down everything that you know that's at all related to slope, to equations, to, you know, what is the derivative? Oh, the derivative is a slope. Okay, what does slope mean? Slope is this. Okay. So then you just kind of piece it together and then you get going. All right? Any questions?